Hey guys, today we'll be solving the October 2025 paper of M1. Let's get started. Number 1. Figure 1 shows a sketch of a beam AB, right, with weight 240 newtons and length 8 meters. Okay, the length is already shown. The beam is held in equilibrium in a horizontal position by 2 vertical ropes. The ropes are attached to the beam at the points C and D, where AC is 2 meters. We can clearly see, we don't really have to read this part, it's quite unnecessary. Then we have the beam is modeled as a uniform rod, and the ropes are modeled as light and extensible strings. Okay, very basic stuff. You have this information literally in every single question of M1, pretty much. Now the tension in the rope at D is 90 newtons. Okay, that's something we have. So we're going to label that, okay? We're going to label that right here. 90 newton. Okay, and as I've already mentioned that the beam is modeled as a uniform rod, that gives us the green light to label the weight of the beam as well. Where do we label it? Right at the center of the beam. 240 newtons, because uniform means the mass inside the beam is evenly spread out, and therefore the overall weight of the beam will act through the center of the beam. Okay, show that x is equal to 2 by 3. How do we do that now? What is x? X is this distance right here. Okay, what can we do? Okay, so there are two different ways we could approach this problem. One of them being we can consider moments about C, okay, and then we will eventually find out x just from that equation. The other method is, albeit a bit lengthy, okay, not a bit lengthy, it's just one extra step, that is, you would have to find out the reaction force at C, or the tension in other words, because we have a string here. So the tension, you would need the tension at C. How would you find that out? Well, you would have to resolve vertically. So you resolve vertically like this. What are the forces upwards? T and 90. So T plus 90 will be equal to 240, because the resultant force is 0 in the vertical direction. The beam isn't moving. Okay, so that's how you get the value of tension at the point C. And after you do that, you're going to take moments about D, and I'm pretty sure that is also going to give you the same value for x. Not pretty sure, you will get x, just trust me. So you can do either of these methods. I feel like the first one's a bit easier. You don't have to make that extra step. So let's do that. Okay, moments about C. Moments about C. You write it like this, exactly like this. And then what's the first weight? First force, we have the weight here, 240 newtons. What's the distance of this force from the pivot, from point C? What is this distance? Well, we do know what this distance is. This is going to be 4 meters. How do we know that? Because we know that 240 newtons is in the middle of the whole beam. So this 240 newton divides the beam into two parts of equal length, 4 meters and 4 meters, right? So that's how we know this is 4 meters, and therefore this distance is going to be 4 minus 2 meters. I hope that's understandable. So the first moment will be 240 times 2. And what is this moment? This is what is this, clockwise? Yeah, this is a clockwise moment. Okay, now this clockwise moment will have to be equal to the anti-clockwise moment created by this 90 newtons of force. Okay, so that is our equation. That is the principle of moments, right? Total anti-clockwise moment will be equal to the total clockwise moment. That's all it's about. So this equal to 90 times, what is the distance of this 90 newtons force from the pivot C? What is this distance? Well, how do we find that out? Well, we have the total length of the beam, that's 8 meters, okay? And we know this is 2 meters, so we can say that this distance is 6 meters, as in 8 minus 2, that's 6 meters. Now, if this is 6 meters and this is x meters, isn't this distance just 6 minus x meters? I hope that makes sense. Nothing more to explain there, honestly. So 90 times 6 minus x. Okay, and you write down just one more step. Let's say 480 is equal to 540 minus 90x, and then you can directly write down the answer. Okay, actually do not do that. That brings me to a new point, that is, whenever you have show that questions in a question that starts with the words show that or prove that even, okay? In these types of questions, you always have to show every single step, no matter how silly or simple that step is, okay? So let's say here I'm going to change sides. I'll bring the negative 90x to the other side and take 480 to the other side. I'll show that step as well, and I'll show the final step as well, which is, what is 540 minus 480? It's 60, I think. 60 divided by 90. Okay, and then I'll finally write down the answer, which is 2 by 3. And then after getting the answer, I'm just going to write down shown in brackets. That's it. That's my answer. Now, the rope at sea will break if its tension exceeds 183 newtons. Okay, that is a very important information. So the tension at C cannot exceed 183, and the rope at D cannot break. Okay, good to know. A package of weight W newtons is now attached to the beam at A. Okay, so we're going to label accordingly. We're going to show this W newtons of force at A. Come on. There you go. W newtons. Okay, we have this. Let's get rid of some of the clutter here. And we no longer have this same 90 newtons as the tension at the point D. Okay, because, well, the whole setup just changed, right? We have a new weight here. So of course it's not going to remain the same. So we're going to erase that. And we know what x is. This is just 2 by 3. Let's just label it, because why not? Okay. We also have the weight. That's it. Alright. The beam remains horizontal and in equilibrium. Very important information. The package is modeled as a particle. Okay. Tell me something that I don't know. It is given that the rope at C does not break. Okay. Find the greatest possible value of W. Okay, first you have to understand, what does this exact information imply? It is given that the rope at C does not break. To break a rope, what do you need? You need exceeding amounts of force, right? Now, this constraint tells you that we are able to consider the tension at C as 183 newtons, because that is like the maximum possible value of the tension, such that the rope at C does not break. Okay, so we can definitely label the tension at C as 183 newtons. Okay, and whenever the tension at C is 183 newtons, that is when you're gonna have the max possible value of this W. Okay, now what can we do here? Well, we can consider moments about D, because if I consider moments about C, then what are the moments that I will have to include in my equation? This, the moment created by W, the moment created by the weight of the beam, and an additional unnecessary, might I add, tension at D, the moment that this creates. So we don't want that. Okay, that just means that we need to do an extra step to find that tension out and then solve for W. Right? So we don't want that. we already know what the tension at C is, so why don't we consider the moment at D, and in doing so, we'll eliminate the possibility of this tension appearing in any of our equations. Okay, so let's do that. We're going to consider moments about D. We write that down accordingly. And what are the moments here? So we have 240 Newton, the weight of the beam, creating a moment in what direction? In the anti-clockwise direction about D. Now the moment is the pivot is no longer C, by the way, it's D, okay? So this is going to create an anti-clockwise moment. This W Newton is also going to create an anti-clockwise moment. C is the the tension at C is the only force that will create a moment in the clockwise direction. So you know what to do. Clockwise equal to anti-clockwise. Let's write down the anti-clockwise moment first, which is going to be 183 multiplied by, what is the distance in between? Remember, we already figured it out. It was 6 minus x, right? So we know what x is. So isn't this just going to be 6 minus 2 by 3, which is equal to 16 by 3. So we have 16 by 3 meters. So here we're going to write down 183 times 16 by 3 equal to, what do we have? Okay, now we're going to consider the clockwise moment, the anti-clockwise moments. So let's take 240 first. 240 times the distance from D. What is this distance exactly? Well, we know what this distance is. This is 4 meters, right? And this is 2 by 3 meters. So that is going to be 4 minus 2 by 3. So we're going to label that down over here as well. 4 minus 2 by 3 is 10 by 3 meters. Done. Okay. So we're going to write that down. 240 times the distance from the pivot, 10 by 3, plus we have an additional moment that is created by the force W. So W times, we need this total distance all the way to the pivot D. What is that going to be? Well, we know that total distance from A to B is 8, and we know the distance between D and B, it's 2 by 3. Therefore, the distance between A and D is going to be 8 minus 2 by 3. Okay, what is 8 minus 2 by 3? Just use the calculator, bro. It's going to be 22 by 3. Great. So we have W times 22 by 3. Okay, now we have to solve this. Well, you can already see that on both sides we have a denominator of 3 on every single term. Right, so we can really just cancel that out. Or in other words, we're basically multiplying both sides by 3, and that cancels the 3 in the denominator. But now we basically have this 183 times 16 equal to 240 times 10 plus 22 times W. Okay, so W is going to be equal to 183 times 16 minus 240 times 10 divided by 22. Let's see what that is. That's going to be 24 newtons. I hope that's right. Okay. Did I miss anything? Nope. Great, let's move on to the next question now. Okay, particle P of mass 7m and particle Q of mass 3m are moving in opposite directions along the same straight line on a smooth horizontal surface. The particles collide directly. Okay, they've already drawn the diagram for us. This is the diagram before the collision, and we're always not required to for the examiners when they're checking, but more like you need it, okay? It's going to help you if you draw the diagrams. Okay, so now we're going to draw the diagram after the collision. So this is after. And we're also going to label the masses and the particles, okay? P7m and Q3m. Done. Now, particle P of mass 7m and particle Q are moving in opposite directions, okay? Alright, smooth horizontal surface, the particles collide directly. Immediately before the collision, the speed of P is ku. Okay, well, we can already see that in the diagram. Immediately after the collision, the speed of P is w, and the speed of Q is 2w's. Okay. and that the direction of motion of Q is reversed by the collision. Okay, so direction of Q is reversed. So Q is moving to the left as shown in the diagram before the collision, right? So if its direction is reversed, then it's going to move to the right now. Okay, so let's label that. And what was the speed? The speed is 2w. Now, if you're wondering and if you're confused that, okay, they didn't tell us anything about p, so how do we know in what direction p is moving after the collision? Well, that's exactly right. We do not know. And that information will be used in part B, so wait for that. For now, let's try to find out W in terms of U. Let's solve part A. Another information that we have is the impulse received by Q in the collision has magnitude 7 mu by 2. Okay, so we have the impulse received by Q. Okay, what is impulse? Impulse is force times the time. The time is basically the time of contact. Okay, and the force is the force exerted between the two colliding particles. This is one formula, and the other formula that we have is impulse being the change in momentum, okay? So del P, or in other words, mv minus mu. Final momentum minus the initial momentum, that is the change in momentum. Now, how do you figure out in what direction a certain impulse will be pointing? Well, if you look at this formula right here, impulse equal to force times time, you can clearly see that impulse is related to force, right? In other words, it's actually directly proportional to force. So the greater the force is, the greater the impulse is. But impulse and force, they're both vector quantities, okay? So if force is in a certain direction, impulse is going to be in the same direction. Impulse will follow. So first, you should figure out that in what direction is the force being exerted on Q. And the force is exerted by P, of course. So if P collides like this, then of course P is going to exert a force on Q in this direction. And likewise, due to Newton's third law, Q is going to exert a force on P on the opposite direction, right? Okay, so now we don't really hear about what force is acting on P for now because, well, the question talks about impulse being received by Q. So we'll do that, okay? And now that we know that the force being exerted on Q is to the right, you also know that the impulse is going to be pointing to the right. Okay, now, what formula should we use? F times T or mv minus mu? Well, of course it's going to be mv minus mu because we don't really know any of the forces and or the time of contact between the two particles. Okay, we don't have the information. So let's use that formula. I is equal to, I'm going to just factor out m, so we're going to have m times v minus u. Now, one thing you have to take care of when you use this equation, impulse equal to m times v minus u, is that you have to consider a certain direction as positive. Why, you may ask? Well, it's because impulse and the velocities that you see in this equation, the final velocity and the initial velocity, these are quantities labeled as vector quantities, right? And vector quantities always have a specific direction, and we have to take care of that. Okay? So whenever you have an equation with vector quantities, direction matters a lot, and you're going to have to consider a certain direction as positive. And it's usually best if you consider the direction of the impulse as the positive direction, but sometimes you can choose other directions as well, but I would suggest stick to just considering the impulse direction as the positive direction. So we'll do that. I'm just going to write that down like this: left and positive. If I was to consider the right side as positive, I would label it like that. Okay, now what is the impulse? The impulse is 7 by 2 mu. That is the magnitude, and impulse is facing to the right, and we considered, wait, why am I considering the left as positive? Impulse is pointed to the right. My bad, guys. Okay, so since we're considering the right side as positive and the impulse on Q is also pointing to the right, we're just going to write positive 7 by 2 mu down over here. But if we had considered the left side as positive, we would just add a negative in front of the impulse. Okay, this equal to the mass. What is the mass? The mass of Q is 3m. So 3 times m, and then what is the final velocity? The final velocity of Q is 2w, and it's pointed to the right in the same direction as the direction which we considered positive. So we're just going to write down 2w. There's no need to place a negative sign in front of 2w, okay? Then negative, the minus, the initial velocity. What is the initial velocity? The initial velocity is u meters per second to the left. Now we considered the right side as positive, so if a velocity is pointed to the left, we're going to have to add a negative in front of that. So negative u. Okay, now we can cancel out the m's on either side, and we're going to have 7 by 2u is equal to, we're just going to multiply this 3 inside, and we're going to have 6w plus 3u, because minus and minus make plus. Now we need w in terms of u, right? So let's make w the subject. I'm sure you guys can do this. There's no explanation needed here. 3.5 minus 3 divided by 6. This is 1 by 12u. That is quite a weird answer, but we're gonna have to do with this. Okay. Done. That is it. Meters per... Do we need to write down meters per second? Not really, but even if you write it down, I don't think it's that much of a problem. Okay, now... Notice how they had mentioned that immediately after the collision, the speed of p is w. So we did have the speed of p. It was w, but the only thing that we didn't know was if the direction of motion of p reversed after the collision or not, right? So it could be either to the right or to the left. We don't actually know, but what we do know is the speed of w. Sorry, the speed of p, which is w. So w here, w there. So we have two possibilities, and that possibility is what's going to be helpful in part B. Very useful, actually. Find the two possible values of k. What is k? Oh, k is right here, the initial speed of p. Okay. So we need to work with two possible values of k. Now, imagine particle p didn't change its direction after the collision, so it would have kept moving to the right. Okay, so we would have just forgotten about this. Okay, so if that was the case, can we not just apply the conservation of linear momentum here? CLM means conservation of linear momentum, if you didn't already know. Then you add a colon, and of course in this equation as well you need to consider a certain direction as positive because you're dealing with velocities, and velocity is a vector quantity, so direction matters a lot. We're just going to consider the right side as positive because we are looking at the first possible case where p doesn't change its direction and keeps moving to the right. And you can see the majority of the velocities in this particular case is pointed to the right. Therefore, it's best if we just consider the right side as positive. That's going to get rid of the extra unnecessary negative signs. Okay? So, what is the total initial momentum before the collision? So we have momentum of P, which is 7m times ku, so 7m ku, plus the momentum of Q is going to be the mass multiplied by the velocity is u meters per second to the left, and we consider the right side as positive, so we're going to have to add a negative in front of that speed, or that velocity, equal to, what is the momentum after the collision for this specific scenario, when we're just assuming that P is moving to the right, or the direction of P hadn't changed. So 7mw plus 3m times 2w. Okay, that's it. We have the equation. And now we can also cancel out all the m's here. And keep in mind, we do have w in terms of u, so we could use this here somewhere. 7ku minus 3u equal to 7w plus 6w. Okay, so what do we need? We need the value of k. So let's make k the subject. I hope that makes sense. Making k the subject, we get, what do we get? Okay, 7w plus 6w is 13w, so let's write that down. And the negative 3u comes to the other side, so we have plus 3u divided by 7u. That's it. That is the value of k. But, of course, we don't want this unknown w to be in the equation, right? We can further simplify this because we know what w is in terms of u. Okay? So, and we're supposed to get a numerical value of k, not some expression in terms of w and u. So I hope that's understandable why you need to substitute this into this equation here. So 13 times u by 12 plus 3u divided by 7u. Now would you look at that, you have the variable u in every single term in the numerator and the denominator, so you can just cancel that out. So you're left with an overall numerical value of k, which is what we're looking for in the first place. 13 by 12 plus 3 divided by 7, and that is 7 divided by 12. That is your first possible value of k. And how do you find out the second possible value? Well, we have to consider the second possibility, which is that P could have changed its direction after the collision. So now, instead of considering right, we're going to show the direction to the left. This is very important. Of course, in the exam, you're probably going to be using a pen. So let's say you already have this labeled, you can't erase this. Well, just draw the arrow on top of that. Simple. Okay. You know what? Instead of these W's, you can just directly write down the values of those W's in terms of U, since everything is in terms of U, all the velocities. And this 2W as well, 2 times W, so 2 times 1 by 12 U is basically U by 6. U by 6. Or you could also write down 1 by 6U. Either works, doesn't really matter. Okay, now again, we'll have to consider the conservation of linear momentum, and we have to take a certain direction as positive. This time, we have 2 velocities that are pointed to the right and 2 velocities that are pointed to the left. So it doesn't really matter which direction you consider positive. Considering one over the other isn't going to make the process easier. Okay, so we're just going to consider the right side as positive because my dominant hand is my right hand. Okay, so initial, as in the momentum before the collision, is going to be 7 mku. So 7 mku, the same thing again. Negative 3 mu. Okay. Equal to, now we have 7m times negative 1 by 12u. So negative 7 by 12 mu. Okay. Then we have plus the momentum of q. The final momentum of q is 3m times u by 6. 3m times u by 6 is basically 1 by 6 mu. So now you can see that we are able to cancel the m's and the u's on either sides. Now, what are we left with? We have 7k minus 3 is equal to negative 7 by 12 plus 1 by 6, and therefore the value of k is going to be I might have made a mistake somewhere. 7 by 12 mu, that's fine, negative. Then we have u by 6 times 3. Oh yeah, this is supposed to be 1/2. So guys, this is what happens when you try to take a shortcut. So I would suggest you write down the equation like we did for the first possibility, where I wrote down the velocities separately here, as you can see, and didn't just, write everything all at once, as I did over here. Okay? If you do that, you're going to be more prone to making silly mistakes like that. Okay. This gives you an answer of 5 by 12. That's it. These answers look good enough and look plausible enough, so you know you're right. Okay, these are the two possible values of k. You're done. If you want, you can write an additional statement here. Therefore, therefore k is equal to 7 by 12 and k is equal to 5 by 12. You could write that down, but let's not waste time. Now, a particle p of mass 2 kg moves on a smooth horizontal surface under the action of two forces F1 and F2. We have F1 and F2. We have to find out the acceleration of p. So this is probably the easiest question on this paper. Whenever you're dealing with force and acceleration, you almost always have to use Newton's second law, which is resultant force equal to the mass times acceleration. And I always suggest, whenever you write this equation down, or this formula down, include this summation sign, because that shows you that you know that this formula is, the F in this formula is talking about the resultant force and not just any single force. It's a combination, the sum of all the forces acting on an object. In this case, we have F1 and F2, so the resultant force is just going to be F1 plus F2. That brings me to my next point, that is, whenever you have forces in their vector forms, okay, in their vector form, you're just going to add the vectors up to get the resultant force, okay? You don't have to do those shenanigans that go something like this. Let's say you have a force in this direction, and then you have a force in, I don't know, this direction. Then you would have to find out the resultant, like this would have been the resultant, and you would just use Pythagoras' theorem to find that out, because there's a 90-degree in between them. Nothing like that, okay? When you have forces in vectors, you just add them up. As simple as that. So F1 plus F2 is equal to the mass times the acceleration, so 2 times A. What is F1 plus F2? That's just negative 2 plus 4. That is good. Okay, you know what? Let me write that down. Plus 4i plus 2j equal to 2 times A. Okay, so now you have 2i plus 5j is equal to 2 times A. Okay, and therefore the acceleration is I plus 5 by 2j meters per second squared. That's it. And they didn't specify if they're looking for the magnitude of the acceleration or not. So you should be fine with just the velocity form, the vector form of the acceleration. That is totally fine. But had they asked you for the magnitude of the acceleration, then you would use Pythagoras' theorem to find the magnitude like this: 1 squared plus 5 by 2 squared. That would be your magnitude. But we don't need to find that out right now. Okay, for part B, at time t0, the velocity of p is 3i minus 4j. Okay, so whenever they say something like at time t0, you should understand, you should figure out that you should be able to piece it together that this is the initial velocity that they're talking about. So a very nice information that we have is the initial velocity. We just label that down. Note that down. U is equal to 3i minus 4j meters per second. Done. Now we have to find out the speed of p when t is equal to 3. Okay, so they're saying that t has to be 3, as in 3 seconds have passed. What is the final speed of p? Of course, we're dealing with the vector forms of those speeds, as we call them velocities, So we're gonna have to find out the final velocity first in its vector form, and then we can think about finding the speed. We'll do that later, but first, what do we have? We have the u, the initial velocity, the time, and we had found out the acceleration in part A. So we can easily find out v. It's just going to be u plus at. That is the formula. I hope you guys know this. You guys should remember this. This formula is not going to be given in the formula booklet. And yeah, 3i minus 4j plus the acceleration is I plus 5 by 2j times 3. That gives you 3i minus 4j plus 3i plus 15 by 2j. And now we're just going to have to combine the I components and the j components. And that's going to give us 6i plus 7 by 2j meters per second. Also, guys, if I make any mistake in this video, please feel free to comment down below and I'll rectify that. And I'll just pin my comment. That should be fine. Okay, but I really hope I don't make any mistakes, and I haven't made any so far. Okay, so this is the final velocity at t is equal to 3. So now we have to find out the speed. And what is speed? Speed is the magnitude of a velocity's vector form. So we can write this down like this. Magnitude of v is equal to the speed equal to square root of 6 squared plus 7 by 2 is 3.5. So yeah, that is going to give us 6.95 meters per second. You could also write down the exact form first, root 193 by 2, just in case you need to use this in the following parts of the question. But yeah, you can choose what to do, but I feel like this is the best way. 6.95. Okay, and then you use the approximate sign and write this down. Give your answer to 3 significant figures. Or you could also use, 2 significant figures. But I like to stick to 3. Okay, for part C. An additional force F3 Bi plus Cj is applied to P. The resultant of F1, F2, and F3 is equal to this, where lambda is a constant. Okay, good to know. Should that be minus C is equal to 3. Okay, so now we have an additional force, and the new resultant of all the forces F1, F2, and F3 is this right here. Okay, so with the given information, we can already write something like this down. F1 plus F2 plus F3 equal to lambda I plus lambda j. We just multiplied the lambda inside, okay? Now, what is F1, F2, and F3? Well, we already know what F1 plus F2 is. That is 2i plus 5j. We already had that from part A. So 2i plus 5j plus, what is F3? F3 is Bi plus Cj. So let's write that down. Bi plus Cj equal to lambda I plus lambda j. Now, we always have to combine the I components and the j components. So on the left-hand side, we have 2i plus bi. So we're going to factor out I, and we'll write this down, okay? And then we'll do the same for the j component. 5 plus c times j is equal to lambda I plus lambda j. Now, if one vector is equal to another vector, you just equate their respective components. So 2 plus b is equal to lambda, and 5 plus c is equal to lambda as well. Now the problem is, there is no problem. If this is lambda and this is also lambda, that means you can say that 2 plus b is equal to 5 plus c. And that should give you b minus c is equal to 3, right? And since it's a show that question, we would like to show an extra step of 5 minus 2. We'll take no chances. We're going to write every single step, no matter how small it is, or silly it is. So b minus c is equal to 3, and we'll write down shown in brackets. Done. Easy question. Now the resultant F1 and F2 and F3 has magnitude 10 root 2. Find the 2 possible F3 forces. Okay, magnitude being 10 root 2. Okay, what is F1 plus F2 plus F3? It's this right here. So what would be the magnitude of that? Well, the magnitude would be square root of 2 plus b whole square plus 5 plus c whole square equal to, we know what the magnitude is. They've told us it's 10 root 2. So 10 square root of 2, that's it. That is the equation. And if you notice, we already have one equation that includes b and c as a variable, and we just wrote down another equation that also has b and c. So I hope that sort of gives you an idea of what you might need to do. We have to solve these two equations simultaneously to get the values of b and c. So let's do that. Well, we're going to just square both sides, okay, to get rid of the square root, and simultaneously we're just going to expand these brackets. That's going to give us 4 plus 4b plus b squared plus 25 plus 10c plus c squared is equal to, if you square 10 root 2, you get 200. Okay, now you can see that in this equation it's a bit messy. You have b square, you have c and c square. So the ideal thing to do here would be to perhaps eliminate b or even a c, but we can do either. Let's eliminate b. So we're going to have to make b the subject from this equation. B is equal to c plus 3, and we're just going to substitute that in place of b in this equation. So we have, okay, and also these numbers that we have, let's just add those up. So 200 minus 25 minus 4. So on the right hand side we're going to have 171. Okay, now c plus 3, so we have 4 times c plus 3 plus c plus 3 whole square plus 10c plus c square equal to 171, and then we have 4c plus 12 plus, we're going to have to expand this now, c squared plus 6c plus 9 plus 10c plus c squared. That's a handful, and we have equal to 171. Okay, now you can already see where this is going. We're just getting a quadratic expression. So we have 2c squared plus 20c, and these numbers that you see, these constants that we have, we're just gonna adjust that with 171. We're gonna bring the 171 to the left hand side, and we're gonna have an equation that looks like this. I hope that is right and I didn't make any silly mistakes, any errors here and there, but yeah, we gotta move on. I think this is okay. Yeah, I'm just double checking everything. Now what you can do is just use your calculator. Okay, use your calculator to find out the roots to this quadratic expression. So you have 2 and 20 and negative 150, and that gives you c equals 5 and minus 15. But always, whenever you solve a quadratic expression using your calculator, before writing this down, what you should do is write the roots in their factor forms. Okay, so as if you're factorizing this quadratic expression. So when you factorize, it looks something like this: c minus 5 and c plus 15 equal to 0. And then you write down the answer: c equal to 5 and c equal to negative 15. And why are we getting two values of c? Well, that's because they're asking for two possible F3 forces. So two possible values of F3. And we know what F3 is. F3 is Bi plus Cj. Okay, so F3 is Bi plus Cj. So of course we should get two values of c. If you do not get two values of c, that means you have made an error somewhere in the solution. Okay. So we have two values of c. With the two values of c, we can now find out two possible values of b, and make sure they're corresponding values of values of b, sorry. No, values of c, yeah, never mind. So what I mean by that is make sure you get the value of b for the same value of c. As in, let me show you. So let's find out the value of b when c is 5, that is 8, and the value of b when c is negative 15 is negative 12, right? So what I don't want you to do is write F3 as 8i minus 15j. That wouldn't be right, because you're using b equals to 8, and that, which was found out using c equals to 5, and then you're pairing it up with c equals negative 15. That is not right at all, so you should keep that in mind. So when you use 8i, you would have to use 5j. Okay, I hope that is clear and understand. And then we have negative 12i, negative 15j. Done. These are the two possible F3 forces.